Hardware description language.
In electronics, a hardware description language is any language from a class of computer language for formal description of electronic circuits. It can describe the circuit's operation, its design and organization, and test to verify its operation by means of simulation. It also can be described as standard text-based expressions of the spatial and temporal structure and behavior of electronic systems. In contrast to a software programming language, HDL syntax and semantics include explicit notations for expressing time and concurrency, which are the primary attributes of hardware. Languages whose only characteristic is to express circuit connectivity between hierarchies of blocks are properly classified as netlist languages.
Here are the advantages of HDL. HDL allows designers to talk about what the hardware should do without actually designing the hardware itself. Or in other words, HDLs allow designers to separate behavior from implementation at various levels of abstraction. Designers can develop an executable functional specification that documents the exact behavior of all the components and the interface. Designers can make decisions about cost, performance, power, and area earlier in the design process. Designers can create tools which automatically manipulate the design for verification, synthesis, and optimization. There are two most widely used and well-supported HDL varieties used in the industry. One is VHDL, another one is Verilog. Here are the comparison between VHDL and Verilog.
From the comparison, Verilog is easier to learn and use. Verilog is a HDL used to model electronic systems. The language can support design, verification, and implementation of analog, digital, and mixed signal circuits at various levels of abstraction. The language of Verilog is quite similar to C, as it can be easy to understand and use. And HDL is not a software programming language. Here is the difference between HDL and software programming language. This is an example of hierarchical modeling with Verilog. These are data values and numeric literal used in Verilog.
There is three common abstraction levels in HDL. The first one is the behavioral. This module is high-level algorithm is implemented with little concern for the actual hardware. The second abstraction is data flow. It is implemented by specific how data flows between registers. The third one is gate level, that is implemented in terms of logic gates and their connection. The process of HDL is automatically generating a gate level model from either a data flow or a behavioral model. These three common abstraction levels in HDL is the same like in verify logic, which is Verilog. There is an example for three common abstraction, which is behavioral, data flow, and gate level. The example is 4-input multiplexer.
For more information on HDL, here we provide some takeaway notes for your reference. Thank you.